To find more complex life, we need to fast forward to 3.5 billion years ago. And a shallow ocean. These look like rocks, or even plants, growing out of the seabed. Each mound is a colony of living bacteria called a stromatolite. These bacteria turn sunlight into food, a process called photosynthesis. It uses the power of sunlight to transform carbon dioxide and water into glucose, a simple form of sugar. And this magical transformation releases a byproduct, a gas called oxygen. Underwater, the stromatolites slowly fill the oceans with oxygen. The oxygen then turns traces of iron into rust, which fall to the ocean floor to form deposits of iron-rich rock. It's this mineral that will one day be used to build bridges, ships, and skyscrapers. Above the waves, the oxygen transforms the atmosphere. These stromatolites are creating the most important element for life on Earth. Without them, virtually every living thing wouldn't exist. Over the next 2 billion years, oxygen levels continue to rise. And as the planet's spin slows, the days get longer, lasting at least 16 hours. Three billion years after the planet's birth, there's still no complex life. No plants, no dinosaurs, no humans. But the Earth has something unlike any other planet in this solar system. A force with the power to change everything. $1.5 billion years ago, the Earth is a beautiful blue ball, dotted with volcanic islands. Over millions of years, a mysterious force rearranges these islands. Hidden beneath the ocean, the Earth's crust breaks plates. But even deeper, the Earth's core is so hot that it generates movement in the rock beneath. These movements push and pull the plates around the globe, carrying the oceans and islands with them. Millions of years race by. Our planet is alive and changing. Over 400 million years, a vast new supercontinent takes shape. It's called Rodinia. In the shallow waters surrounding Rodinia, stromatolites work their magic for more than 2 billion years, pumping oxygen into the atmosphere. Temperature is 85 degrees, and the days are 18 hours long. But this planet looks more like Mars than Earth. To find life, we must fast forward through time. Watton State, 750 million years ago. A force deep inside the planet rips the crust to pieces. It's as though the world is breaking apart. And there's only one force powerful enough to do this: heat. It escapes from the Earth's molten core, stretching and weakening the crust. Inch by inch, year by year, the great supercontinent is splitting in two. The intense geological activity spawns a mass of volcanoes. They pump carbon dioxide into the atmosphere. The carbon dioxide mixes with water and creates acid rain. When the continent tore apart, many rocks were exposed. These rocks absorb the acid rain, including its carbon dioxide. Vast quantities of CO2 are absorbed out of the atmosphere. Now, there's not enough carbon dioxide in the air to trap the sun's heat around the planet. In just a